Welcome to physics class. In today's class, we shall be discussing about how does a solenoid behave as a bar magnet. There are few similarities between a solenoid and a bar magnet. What are the points that are going to support for the similarities between a solenoid and a bar magnet will be discussed in this video. So let us observe the diagram. Observe the magnetic field pattern in a solenoid and also the magnetic field around a bar magnet. It is very clear that outside the solenoid it is in the form of circular loops. In the same way, in the bar magnet, the pattern of the magnetic field lines outside the bar magnet, it is in the form of a circular loop. The detailed explanation is available in a previous video. You can just have a look where I have explained the complete magnetic field strength and pattern in the solenoid. So which is the first property that is going to support your answer for the similarities between solenoid and a bar magnet? It is the magnetic field pattern outside the solenoid and outside the bar magnet. So the pattern is circular loop outside the magnet. Coming to the magnetic field pattern inside the solenoid and inside the magnet. It is very clearly seen in this picture. The magnetic field lines inside the solenoid are parallel to each other. In the same way, the magnetic field lines inside the bar magnet also are parallel to each other. Now, on observing the direction of flow of magnetic field lines, we can observe that outside the solenoid, the direction of magnetic field lines, if you observe this arrow mark, you can make out it is flowing from north to the south. Even here, it is flowing from the north to the south. In the same way, observe the direction of magnetic field lines in the bar magnet. Here also, they are traveling from north pole to the south pole. Now observe the magnetic field lines direction inside the solenoid and inside the bar magnet. Inside the solenoid, on observing these arrow marks, you can make out inside the solenoid it is traveling from south to north. In the same way, even in the bar magnet, the magnetic field lines are flowing in the direction from south to north. So these are the concepts. Repeat. So these are the points which will support our answer to prove the similarities between solenoid and bar magnet, which helps us to prove that even a solenoid behaves as a bar magnet. Next, the last point is, if at all I am going to bring this bar magnet near the solenoid, what happens? Since both are north pole, we can observe there will be a repulsion, a force of repulsion between these two. This also proves that the solenoid is behaving like a bar magnet. From the magnetic properties, we know that like poles repel each other. Suppose I interchange the poles of the magnet. Now I bring the bar magnet near the solenoid. What happens? There will be a force of attraction. That is, it will be attracted towards the solenoid because opposite poles attract. So this also proves that solenoid is behaving as a bar magnet. So let me recall. I'll repeat. What are all the similarities between a solenoid and bar magnet so that it proves the solenoid is behaving as a bar magnet? First is the magnetic field pattern. Magnetic field pattern in solenoid as well as the bar magnet, that is circular loop in both the cases, that is outside and inside they are parallel, which is same in both the solenoid as well as a bar magnet. After the pattern, we can observe the magnetic field direction. How is the magnetic field direction outside in both the bar magnet and the solenoid? It is traveling from north to south. How is the magnetic field direction inside? It is from south to north. This direction is same both in the solenoid as well as a bar magnet. Next comes the last point, that is like poles repel. When you bring a bar magnet near the solenoid, you can either observe repulsion or attraction, proving that the solenoid, when the current is passed through it, there is polarity generated. So like poles repel, unlike poles attract. We can also prove that a solenoid is behaving like a bar magnet with the help of Maxwell's thumb rule. Let me know in the comment section if you need a detailed explanation about that. Now let us see the differences between the solenoid and bar magnet. Even though we have few similarities between a solenoid and a bar magnet, there are few differences also among them. So let us discuss about the differences between the solenoid and a bar magnet. So this video will be giving you the complete picture about how a solenoid behaves like a bar magnet, what are the similarities between these two, and what are the differences between these two. Now let us discuss the differences between an electromagnet and a permanent magnet. As the name tells, the permanent magnet, it is a permanent magnet that cannot be readily demagnetized. What do you mean by demagnetized? Its magnetic properties cannot be removed or nullified. But whereas in an electromagnet, it is a temporary magnet. That is nothing but, in the case of solenoid we have discussed, it is a temporary magnet. It can be readily demagnetized by stopping the current through the solenoid. You can refer to our previous video in which we have discussed the magnetic field strength and pattern of a solenoid and how it can be demagnetized. As soon as we stop the flow of current through a solenoid, it will lose its magnetic properties. Hence, it will also stop behaving as a magnet. So that is the meaning of the first point. It can be demagnetized by stopping the current through the solenoid. Coming to the second point, the magnetic field strength can be changed. In an electromagnet, the magnetic field can be changed. If at all we want to increase the magnetic field, we will increase the turnings in the coil. Hence, the current flow also increases. Hence, the magnetic field will increase. Whereas in a permanent magnet, the magnetic field strength cannot be changed. Electromagnet, it produces a very strong magnetic field, whereas a permanent magnet, it produces weak forces of attraction. Nothing but the magnetic forces are weak. In an electromagnet, the polarity can be changed by changing the direction of the current. Just now we have discussed that the polarity, nothing but the north and the south pole, can be interchanged in an electromagnet by changing the direction of flow of current. Whereas in a permanent magnet, the polarity is fixed and cannot be changed. That is, the north and the south pole of a permanent magnet can never be changed. How are these electromagnets prepared? It is made up of a soft iron, whereas the permanent magnets are made up of steel or alloys. I request you to subscribe our channel so that we can upload more videos. Hope this class was useful.